The water tank is pressurized by the manometer. The gate AB is hinged at A and supported by a stop at B. Determine the reaction on the stop if the gate is 1 meter wide into the screen. So this is the gate AB, 1 meter into the screen or 1 meter perpendicular to the paper if it is on paper. So let's draw the free body diagram. We will not show the reactions at the hinge because they are not involved. We'll just locate center of pressure and centroid. 1 meter from A, 1 meter from the bottom also is the centroid. Then distance between centroid of area and center of pressure, where F acts, is E sub V. So this is the reaction on the stop. So let's set up equation. The moment arm of F is 1 plus E sub V. So summation moment about the hinge equals 0. Reactions are not shown at A because they are not involved in the moment summations. So F sub S times 2 equals Fs times quantity 1 plus E sub V. So that's the working equation, where F is pressure at the centroid times area. We cannot use gamma bar H this time because the surface is not exposed to the atmosphere. Actually, we can, but the best way is to use this alternate formula because this is also gamma bar H, where gamma is the gamma of the liquid in contact with the gate or in contact with the surface, which is in this case water. So to solve for the pressure at the centroid, we sum up pressure from here, which is 0. We go down, this is mercury. Then we jump across down to centroid. So 0 plus 13.6 times 9.81 times 0.8 plus 9.81 times quantity 5 plus 1, because this is 1, this is rectangular, half of 2, equals pressure at the centroid. So pressure at the centroid is equal to 165.59 kilopascals. Having found the pressure at the centroid, we multiply it by the area of the gate. The area of the gate is 1 meter by height 2 to solve for the force. 165.59 times 1 times 2 equals 331.18 kilonewtons. Then E sub V. But before that, we use the formula pressure at the centroid equals specific weight of liquid in contact with the gate, which is water times bar H. So pressure at centroid equals gamma water times bar H. 165.59 equals 9.81 times bar H. So bar H is 16.88 meters. So it cannot be seen in the figure. It is above imaginary. Then we solve for E sub V, which is for rectangular section area, height of rectangle square over 12 bar H, remember? So 2 square over 12 bar H, 16.88. So E sub V is 0.01975 meter. Substitute above, we can now compute for Fs. Fs times 2 equals F 31.18 times 1 plus 0.01975. So F sub S is 168.9 kilonewtons. So here is the alternate solution so that you will have another way of solving it. Instead of this, you might not believe with this solution. I want you to believe. Let's use the pressure diagram. Let's compute the pressure at A and the pressure at B. So pressure at A is 13.6 times 9.21.8 plus 9.81 times 5 at A level. So pressure at A is 155.78 kilopascals. The pressure at B is pressure at A plus 9.81 times 2. So this is the additional pressure, 9.81 times 2 only. 155.78 plus 9.81 times 2. So the pressure at B is 9.81 times 2 or 19.62 kilopascals greater than that at A. So if we draw the pressure diagram and use volume instead, So this is 155.78 uniform pressure. Then the pressure at the bottom is 155.78 plus 19.62. This 19.62 is 9.81 times 2. Again, we will not show the reactions at the hinge. They are not involved in our moments summations. So, of course, for this rectangular pressure diagram, its location centroid is 1 meter. Take note, this is volume and it is 1 meter perpendicular to the board. For this triangular portion, the location of the centroid is 2/3 of height 2. 2/3 of 2 is 4/3. So our working equation, if you sum up moment about A, is Fs times 2 equals F1 times 1 plus F2 times 4/3. So F1 is volume of pressure diagram. It is equal to 155.78, height 2, then perpendicular to the board 1. So F1 is 311.56 kilonewtons. F2, on the other hand, is volume of this pressure diagram, area of triangle times perpendicular to the board, 1 meter again. So 1/2 or 0.5 of 19.62 times height 2 times perpendicular to the board 1. So F sub 2 is 19.62 kilonewtons. Finally, summation moment about A equals 0. So Fs times 2 equals F1 times 1 plus F2 times 4/3 because we already set up this moment arms. Solving for Fs, it should be equal to that, 168.9. So you have to analyze it in your own way. You have to select, but for me, this is the best way, shorter way, so that I will not draw this free body diagram anymore. But if you find this easy and shorter, then do it. I'll only apply this for very complicated situations, like if the gate is in contact with different liquids. In this case, it is only in contact with one liquid. So for me, this is the easier way. But when it is in contact with different liquids, the solution is the better way, so that we will not compute so many vis-a-vis. Okay, that's it.